Okay, today we're doing 4-8 in the book. Write equivalent expressions. A new box of pasta claims that it contains 25% more than the usual box. What expression shows the amount of pasta P in the new box? Okay, so the amount of pasta in this new box has 25% more pasta. So what it is it's the amount of pasta that's in this box, which we could say P, that's P, okay? The amount of pasta in the original box, we're gonna call that P, plus 25% of the amount of pasta that was in this box. So plus 25% is 0.25 of the amount of pasta that was in that box, so P. So it's the original box, which is P, plus 25% of the original box, okay? And that is how much is going to be in this big box. Now P plus 0.25P is 1.25P. That's the expression. And since the coefficient of P is greater than 1, that means it was a percent increase, which makes sense because it's 25% more. Try it. Joe is buying gift cards that are on sale for 15% off. He uses C minus 0.15C to determine the sale price of gift cards. What is an equivalent expression that Joe could use also to determine the sale price of the gift card? So C minus 0.15C, remember this is 1C. So 1C minus 0.15C is 0.85C, okay? So basically, I don't really like this diagram, but over here you would put 0.15C, okay? So it's the cost minus 15% of the cost, and that's 0.85C. And then if you added these two things together, you would get the total cost, because that's 1C. How do you know if an expression is describing a percent increase or a percent decrease? It's describing a percent increase if the coefficient is greater than 1, and it's just describing a percent decrease if the coefficient is less than 1, okay? So it is describing an increase if the coefficient is greater than 1, and it is describing a decrease if the coefficient is less than 1. Okay, analyze equivalent expressions. You don't have to write anything for this. I'm just going to talk you through it. Some middle school students will use 1-foot tiles to create a frame and a large square to determine the number of tiles needed. Sorry, I'm like skipping lines. To create a frame around a large square mural with side lengths S feet. 3 students each wrote an expression to determine the number of tiles needed. Are these expressions equivalent? Explain. So this is saying that from here to here is S plus 1, and then from here to here is S plus 1 because it's a square, and it's saying that there's 1, 2, 3, 4 of those, so it's 4 times S plus 1. If you distributed this, that would be 4S plus 4. Let's look at this one. This is saying that from here to here is S, and this little piece is 1. So it's saying that basically you have 1 here, you have 1 here, you have 1 here, and 1 here. So it's saying that there's 4 S's, so that's 4S, and then plus 4. Same expression, equivalent. This one is saying that from here to here is S plus 2, from here to here is S. So we have S plus 2, there's 2 of those. So that's where this part came from. And then we have 2 S's. If we distribute this, this becomes 2S plus 4 plus the 2S in front. So 2S plus 2S is 4S, and then plus 4. So they're all equivalent expressions. Example 3. Interpret equivalent expressions. A table with a rectangular top has been extended with a table leaf as shown. Multiply 3.5 times the quantity 6.5 plus x to write an equivalent expression for the total area of the extended table. What does each term of the equivalent expression tell you about the table? So if we just look at the diagram, from here to here is 6.5, from here to here is 3.5, so this is going to be the area of the table, and then here's the leaf. We have x, and then this is obviously 3.5. We're going to distribute here. So 3.5 times 6.5 is 22.75. Plus 3.5x. Okay, so the 22.75, that's 3.5 times 6.5, right? So that's the area of the table. So area of table, top, and then the 3.5x, well, this is 3.5, right? So when we multiply 3.5 times x, that's the area of the leaf. The leaf is what they call a piece of a table that you're adding into the table. I have a leaf in my dining room table. You might too. If you have a dining room table at home, you might have a leaf in it that you could put in for like special occasions. Okay, try it. The total area in square feet of the rectangular stage that has been widened by x feet is represented by 1,900 plus 76x. Use the distributive property to factor the expression. What does each factor in the equivalent expression tell you about the stage? So we are going to factor out a 76 here, because 76 goes into both of those terms. So now I have to think 76 times what is 1900? And you might have to just kind of go on your calculator. 1900 divided by 76 is 25. And then 76 times what is 76x plus x. So this would really be the 25, and this would be the 76. This is 25 plus x is this part, and then 76 is this part. So the 76, that represents the length, and the 25 plus x represents the width with the extension. Okay, rewrite the expression 12x plus 8 to find an equivalent expression. Show 3 possible expressions. So we can factor out a 4 in this. So if we factor out a 4 times what is 12x? Well, that would be 3x. 4 times what is 8? That would be positive 2. Another thing we could do is we could just reorder the term. So instead of 12x plus 8, we can write 8 plus 12x. That's the same thing. Another thing that we could do is we could break this term up if we want. We could say 6x plus 6x plus, we could even break up this term, 4 plus 4, right? That would become 12x plus 8, 12x plus 8. So there's like so many different things you could do. A rope is used to make a fence in the shape of an equilateral triangle around a newly planted tree. The length of the rope is represented by 9x plus 15. Rewrite the expression to represent the 3 side lengths of the rope fence. So we are going to factor out with this, so we can take out a 3, and if we factor out the GCF of 3, we're left with 3x plus 5. What is the length of one side? 3x plus 5, right? Every side is 3x plus 5, and there's 3 of them. Last but not least, the expression x minus 0.35x represent 35% off the cost of an item x. How is this equivalent to multiplying x by 0.65? Well, if you do 1x minus 0.35, if you do 1 minus 0.35 in your calculator, you're going to get 0.65x, right? So that's just combining like terms. All right, that's it. You're going to do the practice and problem solving. Have a great day.